stuck. So a lot of these bullets here, they really have to do with the whole big picture of where we'll be at the end of this class, what we were supposed to have gotten out of domains and ranges and things like that, and what is a function. And we're not going to do some of the stuff where we say, what is a function when you're looking at a graph? We're going to wait on that until we get to actually when we're graphing things. So I think this is the quiz on Monday, and then the test a couple days later. And how many slides we got today? We got, it says 14, but I actually the quiz was in there and I added a blank slide. So it's really 12. Okay, a function is a relationship between inputs and outputs. As an example, the amount you or your parents pay for gas depends on how much gas you buy, right? The amount of gas you buy is an input, right? You can't say how much it's going to cost until you know how much you're going to buy. So the amount of gas you buy is the input, and once you know that amount, then you have an output, which is, this is how much I'm going to pay. So we would say that the amount you pay for gas is a function of how much gas are you going to buy. Right? That's math speak. Okay. So this is a table of values that represents that. If you put in 10 gallons of gas, it's going to cost $19.99. If you put in 12, $23.99. Right? So that's a table of values that represents this relationship between inputs and outputs. Okay. And again, I think this might be a little bit of review for you, but the set of the inputs is called the domain. The set of the outputs is called the range, right? So if you're asked, like, here's a table of values, write down the domain, then you should write it like this. And to be perfectly accurate about it, you use these little curly brackets here, which are called set brackets. And then you write down the numbers that were the inputs. That's the domain. And the range, again, using the curly set brackets, and then put in all those values. That's the range. Is that exactly what you remember? Domains and ranges? I mean, I'm just sure that you probably spent a lot more time talking about this in terms of x's and y's. And when we do that, we're actually talking about graphs and x-axis and y-axis, but we're just not there yet. Okay. Okay, Kyle? Okay, so not every relationship between inputs and outputs is a function, right? To be a function, there could only be one output for every input. This would be an example of when it's not a function, right? And you go over here and see, I've got an input of 3 here, and that's associated with an output of 7, and it's associated with an output of 8. That would mean it's not a function. Right? You could only have one output for every input. Usually when you're looking at a table of values, when you see a repeated value in the inputs, that means it's not a function. But just think of the word function. Function, we're using it as a noun, but even as a verb, what does it mean if we say something functions? It works, right? Well, we expect a function in math to answer a question unambiguously. So for example, let's say you've got a job and you work 20 hours and you want to plug into a function that tells you how much you're going to make. You expect to get one answer, not 2. You said, how much am I going to make if I work 20 hours? And they say, well, maybe you're going to make 150 or maybe you're going to make 200. You're still like that. But how much am I going to make? I don't know, right? It didn't function. It didn't work because it didn't give you one clear answer. So that's what functions do. They give you a clear answer every time. And when you have something like this, you're not getting a clear answer. If I say, what's the output that's associated with an input of 3, you're going to say 7 and 8. Okay, well that's not clear. So functions have to answer a question unambiguously, clearly. If it's not a function, it's called a relation. I mean, really, usually the way you start is you start by saying everything is a relation, and then some relations are functions because they have one output for every input. So going back to this gasoline thing, was this relationship a function? Okay, so you look in the inputs, any repeated inputs? No, so that's a function. So you look at it and say, no repeated inputs, therefore function. Okay, how about you try this one? This is your you try. Okay, get you to do a little work. Come on, chop chop. Does this table of values represent a function? Why or why not? And then state the domain and the range. Okay, you need to be doing it, right, Connor? Take out a pencil. There's at least that much to write down, right? You got to write the set of the inputs and the set of the outputs for domain and range. A function? Yes. How many said no? Because why? Okay, but are they repeated inputs or repeated outputs? That's okay. It's okay to have repeated outputs. It's not okay to have repeated inputs. Yeah. Okay, how did Felicity ask? How do we know if it's not a function? Because you have repeated numbers in the inputs. Okay? It's okay to have repeated outputs. I mean, just say, here's a function, right? I got a guy doing work on my house right now, and we agreed upon a price. It doesn't depend on how many days that he's there. Okay, so if he's there for 5 days, how much is he going to get? Let's just say it's $1,000, right? If he's there for 10 days, how much is he going to get? $1,000. It doesn't change. We already agreed on that. You know, it's okay that it's the same for every input as long as it's just one answer. That's okay. That's what this is right here, right? Both 1 goes to 2 and 2 goes to 2, but they're going to one number. They're not going to two different numbers. So this is okay. So you've got to say, this is a function, because no repeated inputs. That's a bad one. And then to write the domain, right? Domain is the set of the inputs. So you've got to write it like this. Curly brackets, 0, 1, 2, 4. Okay? Range. Now, usually when you write the domain and the range, you should put them in order, no repeats. So I would start the range with 1, and then I would have 2, and then I would have 5, right? So you have to say, in order, no repeats. That's the domain and the range. Okay. So another way you can represent a relationship, a relation or a function is with a mapping diagram. Right? This is the one we just had on the last slide, and this is the table of values, and this is what's called a mapping diagram. In the mapping diagram, right, you're going to have the domain on the left, the range on the right, and honestly, I probably should have reversed the order to make it 1, 2, and 5, but at least don't put the repeats in there. And then you should have arrows that point from which number in the domain goes with which number in the range. So 0 maps to 5, 1 maps to 2, 2 maps to 2, and 4 maps to 1. So notice what that looks like. Again, when you see these two arrows going to the same member of the range, no problem. That is still a function. What would it look like if it wasn't a function, a mapping diagram? If you have two arrows coming off of the same member of the domain, now that's not a function. That's okay. This one is not. Okay. So let's see both of these here. Is this a function? Why? Because there's two arrows coming off the same member of the domain. Is this a function? Look for repeated inputs or repeated members of the domain. Yeah, so this is no, yes. Right, so this is no because of that. And this is yes because no repeats. Okay, I think I've got one more. So then you do this one. This is the last slide. Is it a function or not? What do you say, John?
No, because there's the 2 is repeated.
Okay, so this one is a no because of that. Who wants to handle the next one? Somebody did. Mike. Okay, so you say this is a yes, right? Because there's no, right, only one arrow from all the domains. Now, if you look in the book and the way they do this here, usually what they're saying inputs and outputs. They're not using the words domain and range, even though they've already introduced domain and range. A lot of theirs say that. I just changed it to domain and range. It's the same thing. The other thing is you're supposed to have arrows. I mean, it should be clear that 3 is mapping to 1 like that. It would not be accurate to not have an arrow showing the direction of that because it does not go in reverse. It only goes in this direction. Okay, so to be accurate, to be attention to detail, make sure you're drawing arrows like that. Okay, and with that, that's the end of that dynamic lesson. And that's the homework, and it's what, 7 problems. Try to count that again, Adam.